Welcome everybody, I'm Adam. And in this problem, we're going to be writing the trigonometric expression sine of arc sine of x plus arc cosine of x as an algebraic expression. Again, what an algebraic expression means is we're going to try to rewrite this in terms of just the variable x or constants. So to start with, just to simplify things, remember that arc sine of x is the same thing as the sine inverse of x. And arc cosine of x is the same thing as cosine inverse of x. So for the rest of the problem, I'll be writing that just a little bit shorter, saves a little bit of time. Now what we notice here is we have sine of something plus something. And what we'll call that something, our sine inverse, is u plus cosine inverse v. Right? And we've seen this before using our sum and difference formulas. The sine of some u plus v is equal to sine u times cosine v plus cosine u times sine v. And we can use this formula. So what are we going to have? Well, so the sine of sine inverse plus cosine inverse coming down here is going to be equal to, well, the sine of u, or the sine of sine inverse of x, times cosine v, or times cosine of cosine inverse of x, plus cosine u times sine of v, or plus cosine of sine inverse of x times sine of cosine inverse of x. So we're trying to rewrite this as an algebraic expression in terms of just x. And it might look like we went in the more complicated direction, but if you remember, at least for this first line here, what do we have? Well, sine of sine inverse, right, cancel each other, leaving us with just x, times, same thing, cosine of cosine inverse. Are inverses of each other. They will cancel, giving us just x. So the first part of the expression is just x times x. And that is added with the cosine of sine inverse of x times the sine of cosine inverse of x. So these two things we're going to have to think a little bit more about. Okay? So we don't have a way to simplify them as they sit, but what can we do? Well, remembering, cosine of sine inverse of some number just represents an angle. So this is actually cosine. We'll think of our sine inverse as just some angle, call it theta. Same thing here, sine of cosine inverse of some number x is also just an angle. We'll call that some angle, say alpha. Now, cosine of an angle and sine of an angle we can find using right triangle trigonometry. So we'll take a look at our diagrams over here. So starting in this right triangle, and taking, say, our angle theta equal to sine inverse of x, and labeling this with our angle theta, our opposite side, our adjacent side, and our hypotenuse. So, what do we know? Well, we know that we're calling theta is the angle sine inverse of x. Well, that implies, taking sine of both sides, that sine of theta is equal to x, or more importantly, equal to x over 1. So what does that tell us? Well, we know the sine of an angle theta is opposite over hypotenuse. So if sine of theta is x over 1, that says that our opposite is equal to x, and the hypotenuse is equal to 1. So how does that help us? Well, what we want again is cosine of theta. And cosine is adjacent over hypotenuse. So if we can find the adjacent, then we can find the cosine. So what do? What is our adjacent side? Well, the adjacent side, using the Pythagorean theorem, is just the square root of the hypotenuse squared, 1 squared, minus the other leg squared, or minus x squared, which is equal to just square root of 1 squared minus x squared, or square root of 1 minus x squared. So that gives us that cosine of theta, or cosine of sine inverse of x, is equal to our adjacent square root of 1 minus x squared, divided by the hypotenuse 1, or since anything divided by 1 is just itself, cosine theta can be taken as the square root of 1 minus x squared. So that's cosine of theta. Well, what we also need is sine of cosine inverse of x, sine of alpha. Same thing, using right triangle trigonometry with our right triangle here. Suppose we have this angle alpha equal to cosine inverse of x. And same thing, we have our opposite side from alpha, our hypotenuse, and our adjacent side. So starting the same way we did up here, we know that alpha is equal to cosine inverse of x. That implies taking cosine of both sides, that cosine of alpha is also equal to just x. And again, namely, not just x, but x over 1. And what is cosine of an angle? It's equal to adjacent over the hypotenuse. So that tells us that the adjacent side of this triangle is equal to x, and the hypotenuse is equal to 1. So what we want is sine of alpha, and sine is opposite over hypotenuse. So to find our opposite side is, again using the Pythagorean theorem, going to be the square root of the hypotenuse squared, 1 squared, minus the remaining leg squared, or minus x squared. Or just square root of 1 minus x squared. So, sine of alpha is opposite over hypotenuse, or the square root of 1 minus x squared over the hypotenuse 1. But same thing, square root of 1 minus x squared divided by 1 is just equal to the square root 1 minus x squared. So we have our cosine of theta and our sine of alpha, and we can plug those in over here. So coming back over, cosine of theta, or cosine of sine inverse, is square root of 1 minus x squared times sine of alpha, or sine of cosine inverse, is square root of 1 minus x squared. So putting this together, x times x is x squared plus square root of 1 minus x squared times square root of 1 minus x squared gives us just the quantity 1 minus x squared. And so lastly, well, we see that our x squared minus x squared will cancel, leaving us with just the constant 1. So what we have is an algebraic expression. Granted, there aren't any x's, but we said x's and or constants, which is what we get in the end. So the sine of arc sine of x plus arc cosine of x is equal to 1. Thank you very much.